So coming to the first question, which of the following is not used in Fiedel-Crafts reaction? So we all know that what bromobenzene, benzene, chlorobenzene all are electron donating group, which favors what? The Fiedel-Crafts reaction. So the odd one out is phenyl acetanilide. Okay, so the first one, the phenyl thing, because this is the only one which is the electron withdrawing group in this electron withdrawing group. Second one, alcoholic potash is used to bring about what? So this is very important. Okay, alcoholic potash, correct? So first thing is we have to know the importance of alcoholic potash. The purpose, in the second question, the purpose of alcoholic potash, or else to be simply writing, I'll write AlC then KOH. Yes, so the purpose of this is for the preparation of alkenes from haloalkane. In the sense what? To convert haloalkane to alkene. This is the main purpose of this. Correct? Haloalkane to alkene. And also this is also called dehydrohalogenation. What is this process called? Dehydrohalogenation. Okay, dehydrohalogenation. Of hydrogen halide is eliminated from what? The adjacent carbon atom and producing a alkene or a double bond. So don't worry, this is something you will see in most of the question. Dehydrohalogenation and the alcoholic potash. So even if you don't want to study, we will study this thing. Okay. So alcoholic potash used to bring about what? Dehydration, dehydrogenation, dehalogenation, dehydrohalogenation. So it is last one, dehydrohalogenation. Next question, again third one is based on this. Haloalkane, the presence of alcoholic potash, that is alcoholic KOH, undergoes what? Fourth one, elimination. I'll come again to this question. Why? In the sense, this is what haloalkane to alkene. Correct? Haloalkane to alkene. In the sense, if I take a simple example, KOH, if I take the alcoholic potash, plus let me take any alkyl halide. So I'll take CH. Let me take this particular compound. Okay, let me take this thing. So what is my end product? Basically, I'll be getting C double bond C. Correct? Plus KCl and H2O. So that thing I'm not giving much importance, but still. So mainly this is what? Mainly it is eliminating, in the sense the hydrogen halide. The hydrogen halide is getting eliminated. In dehydrohalogenation, the hydrogen halide is getting eliminated. So it is basically an elimination reaction. Okay. So it is basically an elimination reaction. So for the third question is also what? Option number 4. So these are kind of a direct question. Next one, Grignard reagent. Grignard reagent is not prepared in aqueous medium, but prepared in ether medium. Why? The fourth one. Not prepared in aqueous medium, but prepared in ether medium. Why? What happens? First option, the reagent is highly reactive in ether. Second one, it is insoluble in water. Third one, reagent becomes inactive in water. The last one, the reagent reacts with water. So what happens is that, first of all, in this itself, it is given aqueous medium. Obviously, it will react with the aqueous medium, right? That is the main thing, correct? To form alkane. So obviously, it reacts with the water. Water is the, if it is insoluble or not, that is not a problem for us. The main problem is what? Basically, the main thing is it should not react. If the reagent becomes inactive, that is option number 3. That is not at all a question. Correct. It's not prepared in aqueous medium because the reagent reacts with water. So better let me write the equation for this. Then I think it will be clear. The fourth question. If I take water and Grignard reagent is RMGX. Yes, RH. And what will happen? So this H2 I can write as HOH if you want. Okay. Yes. So one of the HO, this HO will be going with what? MGX. HO MGX and RH will be formed. So the basic reason is what? Grignard reagent is not prepared. I'll write down in words. Grignard reagent is not prepared in aqueous solution because the reagent produced reacts with the active hydrogen, correct? RH, the active hydrogen of water to form what? Alkane. Reacts with the active hydrogen of water, active H of water, to give alkane. Okay. Next one. This is again a direct question. The fifth one. On treating a mixture of two alkyl halides with sodium metal in dry ether, 2-methyl propane was obtained. 2-methyl propane was obtained. Yes. So they are asking the alkyl, what are the alkyl halides used to get 2-methyl propane? So obviously we know that it is what? Chloromethane and chloropropane. But we have to know which of these things, because the first option is 2-chloropropane and chloromethane. Second one, chloromethane, chloroethane. So I can cancel out what? Option 2 and option whichever is having ethane. So it is between what? Option 1 and option 2. So let me write down the reaction here. So I'm getting what? Basically, I'm getting 2-methyl propane. So write down the reaction. If you write down the reaction, you will get it. Draw the 2-methyl propane. Correct. How do we get this thing? 2-methyl propane. So I had to add 2-chloropropane. 2-chloropropane. Yes. And what? Chloromethane, in the sense CH3Cl. Correct. And then what I have to add? Plus 2-chloropropane. To get this compound. So I have to mark The fifth one as option 1 directly. 2-chloropropane and 2-chloromethane. Option 1 is the correct answer for this. Yeah. Sixth one, ethyl chloride on heating with AgCN forms a compound X. The functional isomer of X is which one? Sixth one. With silver, ethyl chloride on heating with silver cyanide forms a compound X. The functional isomer of X is which one? Yes. Again, it is a direct one. It is the second one is the option C2H5Cl. Good. See, I'll tell you this thing. If you're getting confused with this, okay, the sixth one. So in sixth question, ethyl chloride heating with AgCN, correct? So the main important thing what you have to know in this question is sixth one. Suppose sixth one, the ethyl chloride, correct? I'll write down the steps only. C2H5 Cl plus what? AgCN, correct? So it will form what basically? It will be forming which one? C2H5 what? NC, correct? So what is this thing? What is the compound name of this? Is it isocyanide or is it cyanide? Ethyl cyanide or ethyl isocyanide? Yes, correct. So basically, telling about this paper, okay. So whomever has marked the first option and the second option, this is basically a grace mark question. Okay. So if you have marked any of these two things, you will be getting the correct thing, or else any of the things. This is a grace mark question basically. But why I took this particular thing is that we have to know this concept. Isocyanide will be our major product. Isocyanide will be our major product. So this is important for us. Yes. Next one, the seventh one. Two molecules of isopropyl chloride with metallic sodium of ether in ether gives which one? So this is again a pretty much direct question. Butane, 2-methyl butane, 2,3-dimethyl butane hexane. So this is a direct textbook question. Now let me come to the thing. Next one, eighth one. An alkyl halide reacts with alcohol ammonia in a sealed tube, and the product formed will be what? Secondary amine, primary amine, a mixture of all the three, tertiary amine. This is again a direct question. So it's a mixture of all the three amines. We'll get everything. Okay, so the eighth one is third. So it's again a direct thing. Now let me see whether any SN1 or SN2 mechanism is here. Let's go to that. Reaction of methyl bromide, 15th question. Reaction of methyl bromide with aqueous sodium hydroxide involves which one? Inversion of configuration, SN2 mechanism, racemization, and SN1 mechanism. Let me know the answer of this. 15th one. Is it SN1, SN2, racemization, or inversion of configuration? Reaction of methyl bromide, CH3Br, with aqueous sodium hydroxide. And why? If I ask you why. Okay. So racemization is nothing but what? Seeing the mirror image. Seeing the mirror image. Okay. In the sense left will become right, right will become left. So maybe once the class is over, I'll tell you. Now coming to the SN2 or SN1 mechanism, whenever this is there in the answer in the question paper, so 50% of chance will go to these things. Okay. So these things already you know it. First, write down what is the compound we are talking about. CH3Br. Is it a primary alkyl halide? Just tell me that. Is it a primary alkyl halide? Or secondary tertiary, what do you think? CH3Br. Yes. So in SN2 mechanism, okay, in SN2 mechanism, primary is greater than secondary is greater than tertiary. In SN1 mechanism, tertiary is greater than secondary greater than primary. So SN2 mechanism favors what? Favors primary alkyl halides. Okay, so this favors primary alkyl halides. That's all. So our option is SN2 mechanism. Now let me go to some other thing. Some of the questions are one more thing is here. N-propyl bromide, 9th one. N-propyl bromide on treating with alcoholic potash. So N-propyl bromide, alkyl halide with alcoholic potash. What I am getting? Anything with alcoholic potash is giving me what? Alkene. Correct? So directly I can mark 3. So don't worry if you have forgotten this. We just now discussed the very first question. Alcoholic potash, this one. Correct? What I'm getting? Alkene I'm getting. That's it. Dehydrohalogenation or elimination. That's what I told you. Even if you don't want to study, you will study it. It will be there in the head. Whenever alcoholic potash is there, KOH will get alkene. Now let me see your other thing now. Which one of this is also very interesting thing. 17th question. Which one of the following is not true for the hydrolysis of tertiary butyl bromide with aqueous NaOH? Not true. First one, the intermediate formed is carbocation. Whether it is SN1 or SN2, intermediate, obviously carbocation is formed. Next one, reaction rate occurs through SN1 mechanism. Let's see the previous thing, just now what I told. Not about the alcoholic potash. SN1 favors what? SN1 favors tertiary mechanism. Correct? SN1 is favoring what? Tertiary mechanism. So I'll write down here. SN1 is what? Tertiary greater than, secondary greater than, primary. So tertiary butyl halide is what basically? Butyl halide. That is correct. The statement is correct. The statement is correct. Tertiary butyl halide. This is also correct. But the question here is not true. Rate of reaction doubles when the concentration of tertiary butyl bromide is doubled. Okay, we will keep it aside. Okay, maybe some of you may have confusion. Next one, rate of reaction doubles when the concentration of alkali is doubled. First of all, alkali is not at all an important factor. Correct? Alkali is not at all an important, whether it double or triples, it is not at all our problem. The rate of a reaction, it depends on what? The rate of a reaction depends on the concentration of the tertiary butyl bromide. So rate of reaction doubles. This is also true. 17 to 1. This is also true. Correct? So the last one is what? The rate of reaction doubles when the concentration of alkali is doubled is there is only not true one. So our correct answer is fourth one. In the sense false. It is independent of the alkali. I'll write down words, then only you'll understand. Rate of the reaction is independent of the alkali, independent of concentration. Correct? So the concentration doubles or triples, we at least bother about it. So again here, what we are doing is we are using the elimination technique. We are eliminating the what? The right answers, because here it is not true. So obviously you have to eliminate the right answers. Let's see any other similar question is there. One more question I got. Question number 20. Which of the following is not true for SN1 reaction? Favored by polar solvents. Not true. SN1 reaction means CH solvents or product, because it is favored by. So SN1 reaction is favored by these things. Okay, water. Now tertiary alkyl halide. Just now we discussed about tertiary butyl halide. Correct. So this is also our correct one. It relates to SN1 reaction. Third one. The rate of reaction does not depend on the molar concentration of the nucleophile. Okay, and the last one, primary alkyl halide generally react through SN1 reaction. Primary alkyl halides react through SN1 reaction. So again, the question here is what? Not true. So the nucleophile is the most important thing here. Correct? Is it so? So what is the answer for this? 20th one. They are told here already in the question. Option 2 we are given correct. Yeah. Sorry, the internet got disconnected. Yeah. So I think we were in the last one. Correct? In this one. So already we had discussed here what tertiary alkyl halide generally react to SN1. So can I say in the fourth one, primary alkyl halides will generally react to SN1? If I'm just seeing the reactivity series of SN1, the reactivity series of SN1. Okay, if I'm just seeing the reactivity series of SN1, it is what? Tertiary greater than, secondary greater than primary. So primary is least favored. Primary is least favored. So it generally doesn't react to the primary. So answer is option number 4 for this. Clear? Yes. One more thing. An incorrect statement with respect to SN1 and SN2 mechanism for alkyl halide is which one? Incorrect statement. So you'd look for the incorrect statement. Question option 2, competing reaction for an SN2 reaction is rearrangement. Okay. SN1 reaction can be catalyzed as Lewis acids. Okay. A weak nucleophile and a protic solvent increases the rate or favors SN1 reaction. Next one, the first one is a strong nucleophile in an aprotic solvent increases the rate or favors SN2. So here again we have to look for what basically? We have to look for which one? Which is the incorrect statement in this? 22nd one. So what do you think is the correct option for 22nd one? By eliminating or whatever it is, what do you think? So for this, we have to know the concepts really clearly. SN1, I told you what is SN1. It is a polar solvent. It is a protic solvent. Correct. And SN1 is also a weak nucleophile. SN1 means weak nucleophile. So SN2 will be what? Strong nucleophile. Yes. So this is the correct thing. 1 and 4 are correct. Again, I got 50-50% chance, which is my correct thing. This is an incorrect statement I have to say among this. Competing reaction for an SN2 reaction is rearrangement. Then SN1 reaction can be catalyzed by some Lewis acid. Among this, which is the incorrect one? 22nd question. So for this is a highly conceptual question. If we know the concepts, then only we can answer this kind of questions. So clearly we know that in SN2 mechanism, okay, suppose we are getting confused, I just wanted to write down here. In SN2 mechanism, okay, there is no rearrangement. There is something called inversion. So in my cat and cow story, I have told what it is. So there is no rearrangement. Inversion takes place in SN2 mechanism. So in theory, everything will be plain, correct? Whereas in MCQ type, we have to apply those things, correct? So they will give something which is similar to the inversion, rearrangement, but that is not true. Rearrangement doesn't takes place. What takes place? Inversion of the configuration takes place in SN2 mechanism. Yes. So option 2 is the right answer. This is my incorrect one. Incorrect.